So this is exercise 28, question number 1. This third part of this is to use the second method to find the values of A and B. And I think you'll find this one a bit easier than the first one. So let's have a look at it. Again, what we're going to do, the trick here is to set values for x so that one of the constant disappears. And then we can find the other one. That's the idea. So here's our original equation. Assign the value of x so that a disappears. Well, if we look at this particular part of it, if x was 4, 4 minus 4 is 0, so a would disappear. So that's the trick. We let x equal 4. And then we put the value of x equal to 4 into this original equation here and work out what b is. See if you can carry on from there and calculate b. So assigning x equal to 4, we end up with this equation. So we get 0 for a and 8b, so we get 8b equals 24, from which b equals 3. So now we found b. All we've got to do now is try and find the other constants. So what we do now is assign another value to x so that b is 0. So go back to the original equation. What value would x have to make b 0? And then see if you can follow the same method and arrive at a value for a. So pause this video here and have a go. The solution follows. We let x equal minus 4. So plugging x equal to minus 4 in, we get minus 8a equals 24. So therefore a equals minus 3. So we've got our values for a and b now. And as before, we can put those values for a and b back into the original equation to divide this original fraction into two partial fractions. And that's the end of question 1. Now have a go at the question in the textbook.